All right, this video is the sample test for functions trig for trig inverses, identities, and equations. And the inverses portion is actually on a different video, so we're just going to do the equations and the identities. All right, let's start out here on the calculator part with solving algebraically in radians. So it says, when possible, give exact answer. So I'm going to try to show some work for this one rather than just type it into my calculator from the start. This is tangent, and it's a quadratic. So I'm going to factor this thing. And I know I'm going to have a tangent x and a tangent x. And how can I multiply to negative 10 and add to positive 3? Well, if I make that a positive 5 and a negative 2, I've got it. So setting each factor equal to 0, I have when does the tangent equal negative 5? And when does the tangent equal positive 2? Whoops, I forgot my x. So both of these are values that I don't know. They're not unit circle values for when the tangent is negative 5 or when the tangent is 2. So at this point, I'm going to go ahead and go to my calculator. So what I'm looking for is I need to know x would be whatever the inverse tangent of negative 5 is. So my calculator needs to be in radian mode, which I know mine is. If not, you need to check yours. And I'm going to do second tangent for the inverse tangent. And then I need the inverse tangent of negative 5. So the answer to that is negative 1.3734. And inverse tangent, I know if it's positive in the first quadrant. If it's negative, it's down here in the fourth quadrant. So this is the angle that it's giving me right here. But if I look at the domain for my original problem, I want all of the answers between 0 and 3 pi. So I have to think about where else tangent might be negative. Tangent would also be negative over here in the second quadrant. I can also keep looping around the circle because I can go from 0 to 3 pi. If I were to write this as a general form, it would be the answer that I got plus pi n because tangent's period is pi. So let's use our calculator to take this number, and I'm just going to add pi to it. Oops, I didn't mean that little e to come up. All right, so there's one answer, and that's the answer that's over there in the second quadrant. I could add pi again, and I would get 4.9. I could add pi again, and I would get 8.05. Just to show you, if I keep adding pi, I would get 11.9, but 11.19. That answer is too big because 3 pi is a little more than 9-ish. 3 times 3.14. So I know that really I only want the first 3 of these positive answers up here. So I'm going to write those down. So I wrote those down and I truncated all of them to 4 places after the decimal, meaning I just chopped the decimal off. Okay, so let me get that blue gone. And now I need to figure out the second part of my equation, which was when is the tangent 2. So to figure that out, I want to do what is the inverse tangent of 2. That's what my x is. So what's the inverse tangent of 2? That's shift tangent on my calculator of 2, and that is 1.1071. That answer is a nice answer. That's over there in the first quadrant. So I could also remember be plus any multiple of pi for this one. So again, on my calculator, I'm going to do a plus pi, and then just do that a couple times. I can see if I should have 3 answers because tangent should be a positive 3 times between 0 and 3 pi. So I'm going to write those 3 down. I don't want the 10.5 because that's too big. So I had 1.1071 as my first answer. 4.2487 as my second answer for that one, and 7.3903 as my third answer for that one. I also want to show you how we could do this without doing any work other than using our calculator. We could go into our graph menu, again making sure we're in radians. I need to do the tangent of x squared. I need to put parentheses around the outside. The calculator doesn't like if I put the squared where it was over there. Plus 3 tangent of x. If you're using your TI, be sure you close your parentheses after each of these x's, and then the minus 10. So I'm going to graph the left side. The right side is just equal to 0, so I don't need to really graph that. That's just my x-axis. Now, if I draw this, my graph might look crazy, but the important thing to remember is that I needed my domain to be between 0 and 3 pi. So let me go back to my view window. I'm going to change my x-min to 0, my x-max to 3 pi. Right now, my calculator has a y-min of negative 3.1 and a max of 3.1. That's fine. It doesn't matter so much what your y-min and max are, so long as they contain the x-axis. So one of the y's has to be positive and the other has to be negative. So now I can look at this graph and I see I've got my tangent crossing my x-axis. So the only problem when I looked at this graph is it looks like tangent only crosses 3 times. Now, if I went to gsolve and found the root on my calculator, There's the 1.107. That was this answer right here. If I hit the over button, it does go to the next stage, even though that answer is not showing up. I'll show you, and maybe you had your calculator set this way. If I go back to my view window for a second, if my Y min and max had been negative 10 to 10 as standard windows, when I graph that one, then we can see all the crossings. On my Casio, it doesn't matter if I can see them. It'll still find them. On your TI, because you have to do that left and right bound, it is important that you can see them. So there's my first one. There's my second one. Just keep going over third, fourth, fifth, sixth, and you can see all of these answers. That 8.0513, that's this one right here. So you can get all 6 answers just by using the graph of your calculator. The directions did say to show work, so I've also done that. All right, on to number 2 was solve the sine of 2 theta equals 0.72. And in this one, our theta is going to be between 0 and 2 pi. So I already have sine all the way by itself right here. So I need to get rid of the sine. The way I get rid of the sine is by inverse sine. So I have the inverse sine of 0.72. That's going to be a value I'm going to get from my calculator. So let me go back into my run menu here, and I'm going to inverse sine 0.72. So on my calculator, and that was what 2 theta was equal to, because I had a 2 theta inside, right? That gave me 0.8038. When is sine positive? Sine is positive in the first quadrant and the second quadrant. So this is the answer my calculator just gave me, an angle of 0.8. I also need this second answer that would be over here in the second quadrant. So in order to figure out what that angle is going to be pi minus whatever my first answer was, because this little reference angle in here is the same as that little reference angle in there, the 0.8 number. So I've got 2 answers. Oops, dropping my pens. And I also know that the period for a regular sine function would be 2 pi. So each of these answers could differ by any multiple of 2 pi. However, in my real problem, I've got a 2 out in front. So in order to get rid of the 2, I need to divide everybody by 2. So I'm going to take the answer that I have on my calculator right now, and I'm going to divide it by 2. And that's going to give me 0.4019. And when I divide my 2 pi n by 2, it would just become pi n. And that should make sense, because if I look at my original function, putting that 2 inside there changed the period, it shrunk it. So now the period of my sine function would only be pi n, which is why I'm adding pi n each time. All right, so I need all of my answers between 0 and 2 pi, and right now that this is a general solution. Since I've got it in my calculator, I'm going to go ahead and list them out to get the second place. So I've got my 0.4 number that's in my calculator, and I'm going to add pi to that. And that gives me 3.5434. Now again, I'm a double checker, so I like to see if I were to add another pi, would this still be in my domain for my original problem? I would get 6.6. That's bigger than 2 pi, and all my answers were supposed to be between 0 and 2 pi, so I'm not going to add any more there. So now we need to go back to the second part of the solution here, what I had in blue, and I need to find that angle. So I'm going to get that back in my calculator. I got that by doing pi minus, and then I'm going to go ahead and do the inverse sine of 0.72. That way I have my exact value still. So that blue number that I had right there would then have been divided by 2 when I move the 2 over. Oops. Okay. Turning the page, we have write the 3 reciprocal properties. You really need to know all your fundamental identities. Reciprocal is when you flipped something. So I would say that the sine is 1 over the cosecant. I need to know that the cosine is 1 over the secant. And I need to know that the tangent is 1 over the cotangent. Likewise, I could have written the opposites of these. So I could have there that the cosecant's 1 over the sine, the secant's 1 over the cosine, and the cotangent is 1 over the tangent. It doesn't matter which set you write, but you need to know all 3 of the different trig functions. 1b says to write the Pythagorean property using cosecant and cotangent. Well, my first Pythagorean property was that the cosine squared plus the sine squared is equal to 1. Now again, I'm not saying the thetas, but I am writing down a theta or an x. There has to be a variable inside there. And then my other two Pythagorean properties come from dividing this. If I were to divide this whole thing here by a sine squared, then I would have cosine squared over sine squared, which is cotangent squared. I would have sine squared over sine squared, which is 1. And I would have 1 over sine squared, which is cosecant squared. And that's how I get my second Pythagorean identity. So I still do need to know this one. I think on your test, I'm just going to ask you to write them all down and do a brain dump of all of them. And then the third one, if I had taken my original here and I had divided instead by cosine squared, you should realize that cosine squared over cosine squared is 1. Sine squared over cosine squared is tangent squared. And 1 over cosine squared is secant squared. Sorry. So that's the third of the Pythagorean identities. So this is the one the question asked for. We also need to know the other two. By the way, the last two of the fundamental identities are the ratio identities. We also need to know those. The ratio identities are that the tangent is the sine over the cosine, and that the cotangent is therefore the cosine over the sine. So we should know both of those as well. We've got 3 reciprocals, we've got 3 Pythagorean, and then we've got 2 ratios. So you should know all of these things, be able to write them down, and to use them for any of your trig proofs. All right, number 4 is to solve graphically. Again, I'm going to just go into my calculator here. So on the left side of the equation, I wanted the sine of 2x, so that's what I'm going to put in my y1, and that's what I had in there for my last problem. On the right side, I had 2x minus 3. I needed to set my view window to go from 0 to 2 pi. So in my view window, I need to go from 0 to 2 pi, which is where I already was. I can think about this logically, that the sine is going to be between -1 and 1. So my y value is between -3.1 and 3.1, which is the setting for my calculator. Will be fine. I could make them bigger as well. When I draw this, I see I really only have one point of intersection. I go to GSolve, find the intersection, and it is x equals 1.5353. And it was just on 0 to 2 pi, so that was the only answer. All right, we're turning over to the calculator part of the test, or no calculator. And your test may or may not have had this page. These were the inverses, so we're going to skip those because they were in the other video. And then we get to the equations portion of the test. So number 12 says solve for theta, where theta is between 0 and 4 pi. So I'm without a calculator now. I need to use then figure out where is the tangent equal to 1. So where, oops, sorry, that would be theta plus pi over 18 is what's left inside. And then I'm looking for where was the tangent 1. Well, the tangent's 1 when both the opposite and the adjacent were the same thing. And tangent's positive in both the first and the fourth quadrant down here. So my answer would be pi over 4 for the 45-degree angle. If I wanted to write this as a general solution, the easiest way for me to do this is say the period for tangent is pi, so I know if I keep going around the circle, adding any multiple of pi, that will give me another solution for tangent. All right, now I need to get theta the rest of the way by itself. So to do that, I'm going to subtract pi over 18. So I'm going to have to figure out what is pi over 4 minus pi over 18. I need a common denominator to do that. It looks like 36 would be our common denominator. So pi over 4 would be 9/36. And I'm subtracting from that pi over 18. Pi over 18 would be 2/36. So if I do 9/36 minus 2/36, that's 7 pi over 36. So I have here theta is 7 pi over 36. Now when I'm combining these two things, I don't want to put it with the pi n because that has a variable and these aren't like terms. So it's 7/36 pi plus pi n. Now I want all the solutions between 0 and 4 pi, so not just these particular solutions. So 7 pi over 36 is the first one. If I add pi to that, that means I'm adding 36/36. So 7 plus 36 would be 43. Whoops, I didn't mean to put a plus there. That'd be a comma. Here's another solution. So that's 43/36. Now I'm going to add another 36 to that. So that would be 79/36. And I could still add one more 36, which is 115 pi over 36. So I've just added pi 3 times. I added pi again, and I added pi again. So clearly if I added any more, I'm going to be bigger than 4 pi, so I'm going to stop there. All right, number 13. Given the cosine of x is equal to 1/2, state the general solution in radians. So if the cosine is 1/2, cosine is positive in the first and fourth quadrant. And if it's a half, it means that my adjacent side is a half. So that's my short side, and that's my big triangle. So the angle here is pi over 3, or 60 degrees. That could also differ by any multiple of 2 pi, because that's the period for cosine. I also am going to be positive down here. I could answer this question 2 ways. I could easily say this was negative pi over 3, plus any multiple of 2 pi n. That's probably the way I would have done it. The other thing that you could have done for this angle, instead of having a pi over 3 in here, you could have thought of going all the way around in the forward direction, which would mean you're pi over 3 short of making it to 2 pi. So 2 pi would be 6/3, so 5/3 plus 2 pi n could have been your bottom solution as well. All right, number 4 says find the particular solutions in radians where x is between negative pi and 2 pi. Well, I already have a couple of solutions up there. So starting with the first one, the pi over 3, I'll list that one again because that worked. So I was up here at pi over 3. Now I want to say, could I take that one? If I add 2 pi to it, is it going to be too big? Yes, if I add 2 pi, it's going to be bigger than 2 pi. What if I subtract 2 pi and go the other way? Well, if I subtract 2 pi and go the other way, so I'd be going around like this, would I be more than negative pi to the left? Yes, I would, so I can't use that one. Okay, so looking at my other option, I had this negative angle down here, which I could call negative pi over 3, so that's another solution. And then if I hadn't already, I would have added 2 pi to that to get this 5 pi over 3 that I got by going around in the counterclockwise. All right, so there are my 3 solutions. Those are the only 3 ways that I can go and still be between negative pi and 2 pi. So I have to have exactly those 3 and only those 3. All right, let's scroll down to number 14. We have Amos Stake is involved in solving a trigonometric equation in radians. And he writes that the sine of 3x is equal to negative 0.5. So when he's solving, he says, well, 3x, and the first thing it looks like he's supposed to be doing would be to inverse sine of negative 1/2. And he gets those 2 answers. And then from that, he changes his 3x to an x, and he gets this second thing in parentheses down here. So what should he have written for the last 2 lines? Well, first of all, let's just double check. If I were to solve this question, where is the sine equal to negative 1/2? The sine is negative down here on the bottom. If it's going to be negative 1/2, that's the 30-degree reference angle. So this angle I could call negative pi over 6, so that looks good. Plus 2 pi n would be the period for a regular pi function, or a regular sine function, so that's good. Now I've got to get this second angle. Well, how big is this angle? If I go in the forward direction like that, it would be pi minus negative pi over 6, which you could write instead as 7 pi over 6 plus 2 pi n. So that was his first mistake, because pi minus pi over 6 would have been 5/6, which is up on the top, so that wouldn't work. Okay, now let's see what happens in the next step. Next step, he takes and he divides everything by 3. But does he divide everything by 3? Well, if I take my negative pi over 6 and divide it by 3, I'll get negative pi over 18. So that looks good. But I didn't divide the 2 pi over 3, the 2 pi n by 3, so I need to put that down there on the bottom. Also, we decided this answer right here was just flat out wrong from before. That should have been a 7 pi over 6. So then when I divide that by 3, that would have been 7 pi over 18. And then again, what I add to that should be 2 pi n over 3. So that one should have been fixed. So down here on the bottom, what should he have written? Well, what he would have gotten down here at the bottom would be negative pi over 18 plus 2 pi n over 3. and also 7 pi over 18 plus 2 pi n over 3. Okay? So if you're trying to find a mistake, really you're just saying what would the correct way be to do this. Okay, on to number 15. It says the graph shows both sides of the equation. So I've got this 2 plus sine of theta, which is this guy going on up here, right? It's been bumped up 2. And then I've got this over here, 2 cosine squared of theta, which is this part right here. Okay. So I've graphed the left side and I've graphed the right side, and I'm trying to see where they cross to solve the equation. So question A says, from the graph, estimate the solutions of the domain from negative pi to 3 pi. So 2 pi was right here at 12 little tick marks. So that means at 6 tick marks would be my pi. Sorry, I paused and I'm not sure when I stopped talking. So I put on here negative pi, and I was just counting little marks, and 6 little marks was pi. I put on pi, I put on 2 pi, and I put on 3 pi, because I'm looking for all the crossings between negative pi and 3 pi. So starting over here, it looks like we're crossing at 3 pi, so I'm just going to work from the right to the left. It looks like we're crossing at 2 pi. We're crossing a smidge to the left of 2 pi. So not sure where that is. Well, each little mark, 6 little marks made up a pi. So each little mark is therefore a sixth of a pi. So we're a sixth short of 2 pi, which would make us 11 sixths. If you got anything really that was over there in the fourth quadrant, we would have probably been okay with that. All right, so keep backing up. Here's another place where they cross. Well, that looks like it's a sixth more than pi, which would be 7 sixths. Keep backing up. It looks like we're crossing at pi. Keep backing up. We're crossing at 0. Keep backing up. That looks like negative a sixth. And then I can see, and on your real test, this would definitely be in the picture better, but it looks like I'm crossing maybe before negative pi, and based on my other pattern, I know that that's going to be at negative 5 pi over 6. So those are all of the places where my two graphs crossed, and they were, again, estimates. So long as you got close, you would be fine. All right, then in part B, now we're going to do the algebra, and I better come up with the same answers that I got in part A, because it's the same equation. If I'm trying to solve this, I have a quadratic. The problem is I have both sines and cosines in the equation. So instead of writing this cosine squared as a cosine squared, I'm going to rewrite it as a 1 minus sine squared. So now on the left side, I have 2 plus sine of theta is equal to 2 times the quantity 1 minus sine squared theta. So over here on the right, I'm going to distribute that 2, and I haven't touched the left. Now I've got a quadratic. I have to have my first term, my quadratic term, be positive. So I'm going to go ahead and I'm going to move everything, sorry, I keep erasing, over onto the left side of the equation so that these 2 sine squareds can be positive. I already had 1 sine squared on the left, and that was positive. And then when I move this 2 over, 2 minus 2 is 0, so I don't have any left. I need to solve by factoring, so I have a sine squared and another sine, so I can take a sine out as a GCF, and that would leave me with 2 sine plus 1 left inside. Now I'm going to set each factor equal to 0. So for my first factor, I have when is the sine equal to 0? Well, thinking of my unit circle, the sine is equal to 0 here and here, because I've gone up nothing. Within my window, that would be 0. That would be pi. It could also be 2 pi. It could also be 3 pi, because both of those were included. And I could also think of going to the left here and calling this guy a negative pi. So there's a first group of my answers. I'll list them from smallest to largest. So negative pi, 0, pi, 2 pi, and 3 pi. And you can see if I look at my list up here on the top, I had 0, I had pi, I had 2 pi, I had 3 pi, and I had negative pi, which I probably should have had up here on my list in the beginning, so let me add that in. Negative pi up there, and again, it would be a little more clear on your paper whether or not they cross there. Okay, My second factor, I have 2 sine theta plus 1 equal to 0. So I'll move the 1 over to the right, and I have 2 sine is negative 1. Then I'll divide both sides by 2, and I have where is the sine equal to negative a half? Well, the sine is negative down here on the bottom, and these would need to be our 30-degree reference angles or our pi over 6 angles. So starting with my negative answers, I would have negative pi over 6 and negative 5 pi over 6. And I had both of those up above, so that was good. And now let's turn around and also give some positive answers in there. If I went forward, this would be 7 pi over 6. And this would be 11 pi over 6. And again, those were on my list. If I'm continuing up towards 3 pi, well, 3 pi would mean if I start out on my x-axis, that would be 1 pi, 2 pi, 3 pi would include another top half of the circle, but there weren't any answers left on the top half of the circle, which is why I've run out of answers. And those were all of my answers for theta. Okay, I'm going to go ahead and stop this video here so that it's in 3 separate segments. This was the equations, and you can go to the next video if you want to do the identities. Remember, this stuff has to be without a calculator and with a calculator. Both